Hello everyone, my name is João Félix Hartleben Fernandes and I will present the assignment referring to the class of Instrumentation Control of Chemical Process in the Chemical Engineering course in the Federal University of Rio Grande. The assignment is the identification of the system dynamics of a paper dryer kiln and the tuning of level control of communicating vessels. For the identification of the kiln dynamics, it was adapted to the system the sensors DHT11 and LM35, which will measure humidity and temperature inside the kiln, providing the necessary data for the identification. The sensors are connected to the Arduino Uno board, which is connected to the computer, and by means of the Arduino interface, the code capable of turning on the sensors was programmed, and the serial monitor of the interface receives the data from the sensors. A 60-watt light bulb was used for the experiment. In the beginning, by means of pulse width modulation, the applied power was 40 watts, then wait for the system to reach the steady state, and then the power was changed to 48 watts, what's called the step. After the step, wait for the new steady state, and with the collected data, we can proceed to the calculation of the parameters. The dead time is the time the sensor takes to alter its measurement after the step. The process gain is how much the variable affected by the step, in this case the humidity, was modified, divided by the variation of the entry variable, light bulb power. The process time constant is the time for the exit variable to reach the value of 1 minus exponential of minus 1, that is, 63% of its variation.
Hello, my name is Lorenzo, and here we can see the kiln data acquired from the sensors, a graphic of the first run and of the second run, because a duplicate is made to increase the exactness of the data acquired. The gain is obtained by dividing the humidity variation after a step by the power variation after the step. The dead time is obtained from the data list by observing in which time there was an alteration in the sensor measurement. For the time constant, 63% of humidity variation is calculated, and then the data table is used to find the time referring to this value. The results are considered the average of each of the two values. For obtaining the time constant, it was considered that the humidity varies linearly in the interval, thus trying to obtain a realistic value because the sensor only returns integer values of humidity. The identification data are important especially for the calculation of the tuning parameters using the tuning tables, like the Cohen-Kuhn and Ziegler-Nichols open-loop tables. The identification data can also be used to simulate the process in the software Xcos, being possible to even add control to the process. This can be done in the case of another tuning method, the closed-loop tuning.
For the tuning, previous data from the vessel's dynamics identification are used, and with them the tuning parameters are calculated using tables, in this case the open-loop tuning table of Cohen-Kuhn. Also, a simulation is run in the Xcos, applying the process dynamics in order to obtain the ultimate gain and the ultimate period, which will be used in the closed-loop tuning table of Ziegler-Nichols. The ultimate gain is reached when the controlled variable displays a variation with constant oscillation, and the ultimate period is the wavelength of this oscillation. The controller code is programmed in the Arduino interface using the proportional and proportional integral strategy with anti-I wind up. As the sensor returns very variable measurements, the integral of the error will go to infinity, making the control impossible. The derivative control was not applied because of the high variability of the ultrasonic sensor, which would cause the derivative kick, and because this measurement variation is caused by the sensor itself, not by actual variations in the vessel level. For each of the four tunings applied, Cohen-Kuhn and Ziegler-Nichols, P and PI, using the Arduino Nano board as the controller, the data of level versus time was obtained along with the performance parameters EASY, EI, ITSI, and ETI to be possible to evaluate which tuning showed better efficiency.
Here are presented the graphs of the level contour of set point 17 cm and during 200 seconds. We can see that there is offset in some tunings and the high variability of the sensor is evident, but it is perceived that the measurement stays close to the set point. The parent better tuning is the Ziegler-Nichols PI, demonstrating higher proximity to the set point and most uniform variation. Here are the graphics in global scale. By their observation, it is not possible to say which tuning is better. Passing to the performance criteria, it's observed that they corroborate the efficiency of the PI Ziegler-Nichols, although the values are closed between all four tunings. The offset is the difference between the set point and the measured variable. The settling time is the time the system takes to establish the measurements close to the set point. The overshoot is how much the variable surpassed the set point because it came from a point far from it. The rising time is the time for the variable to reach the set point for the first time. And the decay rate is how much the oscillation around the set point decreases.
The EI is the integral of the absolute error. The EZ is the integral of the squared error. The ETI is the integral of the time times the absolute error, and the ITSI is the integral of the time times the squared error. These values represent how much error the variable accumulates during the control. The ones with time multiplying give more weight to errors after a long time and less weight to the initial errors, for time is still low. Follows a recording of the system operation. Note that the pump stays on for a long time in the beginning because the set point is far away. Then we wait for the level to get close to the set point. As it is reached, the pump turns on only when necessary. Thank you for your attention. We hope it was pleasurable. Have a good day.